This presentation is called Normal Probability Part 2, and I strongly encourage you to view the video called Normal Probability Part 1 before you attempt to view this video. I think this will make a lot more sense if you have seen Part 1 first. At the very end of Part 1, we had a little review, and we reviewed the two types of problems I identified for normal probability. I want to repeat what I've said before, which is that no textbook or instructor uses this type 1 problem, type 2 problem approach that I use. So don't expect to read this in a book or hear it from your instructor. It's just an approach that I find to be helpful. So let's review the two types of problems quickly. A type 1 problem, what it is you are given a point or points and you are asked to find out how big the area is that corresponds to those points. And as was pointed out in Part 1, area really simply represents probability or percentage. So the key words in the question that you're looking for to know it's a type 1 problem are find the probability, what is the percentage, some combination of those words. And then on the calculator, the way you're going to solve these problems is by using second vars, normal CDF, and you're going to enter low, high, mu, and sigma. And again, if you look at Part 1, it'll clarify this a little bit, but certainly as we go through the problems in this part, you'll see what these things represent. A type 2 problem is just the opposite of a type 1 problem. In a type 2 problem, you are given the area and you are asked which point or points correspond to the area. So it's just the other side of the coin from a type 1 problem. In terms of what words to look for in the question, this is the trickiest part. For a type 2 question, the way you know it's type 2 is because the type 1 problem words are missing. So you won't find, if you're looking at a normal probability problem and you're looking for these words, if you don't find them, then that tells you it is a type 2 problem. Also, in some type 2 problems, you'll see the word separates or you'll see the word cutoff, and that also tells you that it's a type 2 problem. And then in the calculator, for a type 2 problem, you will use second vars inverse norm. And then you will input the area to the left, mu, and sigma. And again, as we go through the problems in this part, you'll see how to think about those things and how to put them in. So now we're going to do some problems. And here is the first problem. And by the way, it comes from the Triola textbook. It's exercise 13 on page 260. But let's read it. Assume that adults have IQs that are normally distributed. I'm going to stop right there. You'll notice I've highlighted in green that phrase normally distributed. That is really important. That tells you that you're going to be doing a normal probability problem. And immediately, as soon as you see normally distributed, you should be thinking, is this a type 1 problem or is this a type 2 problem? So let's keep reading. Assume that adults have IQs that are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability. I've highlighted that in yellow. There you go. Bingo. Those words tell you that this is going to be a type 1 problem, which means on the calculator we're going to be using second vars and normal CDF. Let's finish it reading it. Find the probability that a randomly selected adult has an IQ that is less than 115. Those words are also important. You'll see in a minute we're going to have to be doing some shading, and what tells us how we're going to shade on our picture is this phrase less than. It could have said greater than 115. It could have said between 110 and 115, but it said less than 115. That's very important. So again, the green highlighted part tells you what kind of a problem it is. The yellow highlighted part tells you how you're going to solve the problem. So how are we going to address this problem? The first thing we need to know is it type 1 or type 2? And we've already covered that. These words, find the probability, tell you that it's a type 1 problem. The next thing we want to do is draw a picture. It says here, this second bullet. Draw a normal curve and shade the area you are trying to find. Before we get to the shading, we have to go through these steps. We're going to draw the normal curve. we're going to plot the mean, which in this case is 100, and we're going to plot 3 standard deviations. Oh, by the way, let's go back. The mean, the symbol for the mean is this Greek letter called mu, and the symbol for the standard deviation is this Greek letter called sigma. So after we plot the mean, we're going to plot the 3 standard deviations, or sigma, above the mean and 3 standard deviations below the mean. And in each case, each standard deviation, each sigma equals 15, because that's what the problem tells us. The problem gives us the mean, which is right here, the 100, and the problem gives us the standard deviation, which is 15. So here I have drawn the curve. So every Bell distribution, every bell curve basically looks the same. And I have drawn an axis here, which I'm calling the x-axis because it has real values. Here in the middle, you see the mean. The mean equals 100. And you see this number 115 here. That is 1 standard deviation above the mean. If you'll remember, each standard deviation is 15. So if you take 100, you add 15, you get 115. That's 1 standard deviation. You add 15 again, you get 130. That's 2 standard deviations. You add 15 again, you get 145. That's 3 standard deviations. Over on the left side of the mean, we're subtracting standard deviations. 100 minus 15 is 85. 85 minus another 15 is 70. 70 minus another 15 is 55. So we're back to these words. We have plotted the mean. We have plotted 3 standard deviations above and below the mean. And now it says to plot x. X in this case is 115. That's this number right here. We're going to figure out the area less than 115. Before we plot that 115 x value, I want to point out one other thing. Every time you see a normal curve, you will see an x-axis. But I want you to know that there is always also a z-axis. You see the z-axis there. They don't show it usually, but there it is, and it simply tells you how far any particular value is away from the mean. It tells you the number of standard deviations any value is away from the mean. So in this z-axis, you'll see 0 corresponds to the mean itself, because at 100 you are not away from the mean at all. But the number 115 is 1 standard deviation above the mean, so its z-score is 1. 130 is 2 standard deviations above the mean, so its z-score is 2. 70 is 2 standard deviations below the mean, so its z-score is -2. And that's why I show this z-axis here, to make it really obvious what we're doing when we find a z-score. Okay, so I have now found my x value, which is 115, and that's right here. And because we're finding a probability that any value is less than 115, I have shaded everything to the left of 115. So less than means to the left. Greater than would mean to the right. So the right edge of our shaded area, or the right boundary of our shaded area, is 115. The left edge or boundary of our shaded area actually is -infinity. It's too small to see here, but it just goes and goes and goes forever. So that's what your shaded area should look like on this question. Because it says less than, your shaded area goes all the way into the left tail. And because it says less than 115, your shaded area stops when you get to 115. And we're going to find out how big this shaded area is, given that the total area under the curve is 1. So here, if we look at the words, this we've already done. It says shade the area you are trying to find. Because the problem says less than, you start shading from the left tail. You keep shading to the right until you reach x, which is 115. And that's what we did. And now you're going to see how easy it is to do this on the calculator. So here's all of our calculator stuff starting right here. We're going to start by going to second VARS normal CDF. So I come over to the calculator, second VARS, and here you see all these choices. Well, there you see normal CDF. So we're going to choose 2. And what normal CDF wants from us is low, high, mu, and sigma. Well, low is the low or left boundary of our shaded area, which you remember is -infinity. And the way we do that is to put in -1e99, and I'll show you how to do that. On the calculator, we use this negative sign. We hit the number 1. Now this e, how do we make the e? If you'll see this comma, this key, see the comma, right above it is you see 2 little e's in blue. Well, we want those e's, although it's only going to show us 1 e. So we hit the second key and the comma key, and that's the e that you want. Again, we want -1e99, so now I'm going to type in 99, and now a comma. And next we want high. So here again, we did low, we just did this thing right there. Now we're going to go do high. High is the high or right boundary of the shaded area, which in our case is 115. So I'm just going to type in 115, and then another comma. What's next? We've put in low, we've put in high. Now we want mu and sigma. Well, if you remember, mu is 100 and sigma is 15. So we just type those in. 100, comma, 15. We close our parentheses. And just here it is, it's shown very plainly. Second var's normal CDF. The low is -infinity. The high is 115. Mu, or the mean, is 100. Sigma, or the standard deviation, is 15. This says the answer should be 0.8413, and let's see. I will just hit enter over here on the calculator, and there's our answer, 0.8413. And that means that shaded area we saw, that represents 0.84 of all of the area under our curve. And to answer the problem, that is the probability that a randomly selected adult has an IQ that is less than 115. Let's do problem number 2. And you'll notice all these problems are set up the way just to kind of make it easier for us. Assume that adults have IQs that are normally distributed. Again, that phrase, normally distributed, tells you you're going to be thinking about, is it a type 1 or is it a type 2? The mean is 100, the standard deviation is 15, just like in the last problem. What is the percentage? Those are some of the magic words that tell you it's a type 1 problem. If you go back and review part 1 of the presentation on normal probability, you will see that that's one of the magic phrases that tell you that you have a type 1 problem. What is the percentage of adults whose IQs are greater than 131.15? If you remember, the last problem said less than some number. The first thing we address is a type 1 or type 2. Well, we already talked about that. These words, what is the percentage, tell you it's a type 1 problem. Now we're going to draw our normal curve and shade the area we're trying to find. We're going to plot the mean. We're going to plot 3 standard deviations. We've already done all this stuff. So this is just like we did on the last one. Then it says plot x, which in this case is 131.5, and then shade the area we are trying to find. Because the problem says greater than, you see that phrase greater than, and I highlighted it up here, you start shading from the right tail. You'll be shading on the right. It says you keep shading to the left until you reach x, which is 131.5. And here you see what this looks like. We've drawn the normal curve. Here's all our mean and standard deviation marks as we talked about before. We went to 131.5, which is right there, and we shade into the right tail. This is called the right tail because it said greater than. So that's what our picture looks like. And this helps us understand what the left boundary of our shaded area is going to be and what the right boundary of the shaded area is going to be. That's the reason for shading, is so that you know what to put in the calculator for left and right, or low and high. So now we're going to the calculator. Second var's normal CDF, just like on the last one. Second var's normal CDF is number 2. Low is the low or left boundary of the shaded area, which in this case is 131.5. 131.5, comma. High is the high or right boundary of the shaded area, which is positive infinity. So this is just like the negative infinity we did before, but without the negative sign. So we go 1, we make our E this way, our 99, our comma, and then mu and sigma, 100 and 15. Close parentheses, hit enter. There you are, 0.01786, which we have rounded here to 0.0179. So that's the answer. The probability or the percentage of adults whose IQs are greater than 131.5 is 0.0179. This one's a little bit different, but starts out the same. Assume that adults have IQs that are normally distributed with a mean of 100 and a standard deviation of 15. Find the probability that a randomly selected adult has an IQ between 90 and 110. Our first issue is always type 1 or type 2. Again, we see the words find the probability. That tells us it's a type 1 problem. Now we are going to draw our normal curve and shade the area we're trying to find. We plot the mean, we plot the 3 standard deviations just like in the other problems. And then we have to plot x. Well, if you'll notice, in this case we have 2 x values. We're going between 90 and 110. So those are both values of x that we are going to put in order to shade the area that we're trying to find. Here we see shade the area you are trying to find. Because the problem says between, you start shading from the low or left x value, which is 90, and you keep shading to the right until you reach the high or right x value, which is 110. So here you see what that looks like. We plotted this point right here, which is 90. We plotted this point right here, which is 110, and we shaded in between those 2 points. So it's going to be very clear that the 90 is the low boundary of the shaded area, and the 110 is the high boundary of the shaded area, and those are the values we're going to be putting into the calculator. So we go to the calculator. Again, because it's a type 1 problem, we're going to be doing second vars normal CDF. So here we go, second vars normal CDF. Low or left boundary is 90, so 90 goes there. The high or right boundary is 110, so 110 goes there. Again, mu is 100. Sigma is 15. We close the parentheses. We hit enter. And we get 0.495, etc. And here's our answer, 0.495. I'm going to return to the picture to point out something that's different in this problem as in comparison to the first 2 problems we did. If you remember, in the other 2 problems, we had shading that went all the way to one of the tails, either the left tail or the right tail. And in those cases, one of your boundaries is going to be an infinity. If it goes all the way to the left tail, the low boundary is going to be negative infinity. If it goes, the shaded area goes all the way to the right tail, the high boundary is going to be positive infinity. But sometimes you get questions where you're not dealing with any tails or any infinities or greater. Instead of saying greater than or less than, they say between. So in this case, we have no shaded area in the tails. All of the shaded area is under the curve and not going into the tail. So that's how this between question differs from those other questions. Here's our next question. Assume that adults have IQs that are normally distributed with a mean of 100 and a standard deviation of 15. This is exactly the same as every other question we've seen. Now it says find the IQ score separating the top 37% from the others. As always, the first thing we have to decide is this a type 1 or type 2 question? Well, the way we do that is we look for these words that say find the percentage or what is the probability, something like that. We can't find those words here. And because they're not here, that means it's a type 2 problem. Also, we see the word separating. See it right there? That also tells us that it's a type 2 problem. As with the other problems, we are now going to draw a normal curve and shade the area we are trying to find. As with all the others, we're plotting the mean, which is 100. We plot each of the standard deviations. Then it says shade the area you were given in the problem. In this case, your shaded area is the top 37%. That means the 37% at the far right side of the bell curve. Top means right, bottom means left. So the top 37 means we're going to be shading to the right. Note the point you are trying to find, which is at the left edge of the shaded area. Now compute the area to the left of that point. The area to the right of that point is 0.37, so the area to the left must be 1 minus 0.37, which is 0.63. So here's what this looks like, but I want to caution you about something. You remember the way we're doing this is we are shading the top 37%, or the 37% toward the right. Well, if you think about it, we don't know how far that goes. We're just guessing. This diagram makes it look like we know exactly where to stop this shading. We don't. But you don't really need to know to solve this problem. You just make a ballpark guess as to how big 37% of the whole area is, and that's what you shade. The important thing to notice is that if this area to the right is 37%, we need to know the area to the left, because that's what the calculator wants to know. So this pink area here is the area to the right, and the light green area under the curve is the area to the left. So if this pink area is 0.37, then this green area has to be 1 minus 0.37, which is 0.63, which is what we're going to be putting into our calculator. So now we go to the calculator, and now we do something a little different. And let me make one little correction here. Now in the calculator, we're going to go to second var's inverse norm. Before we were going to normal CDF. Now we're going to go to inverse norm, and we'll see what that looks like. We'll come over to the calculator, second vars. Here you see normal CDF. That's what we've been doing, but now we're going to go down to this number 3, inverse norm. So I'm going to choose inverse norm. What we need to put in here is the area to the left, and that means the area to the left of the point we are trying to find, and then we're going to put in mu, and we're going to put in sigma. We found that the area to the left of the point we're trying to find is 0.63. And you remember, that was 1 minus 0.37, which was the area to the right. It's very important you get this straight. Keep rereading this bullet right here. See this bullet? Read this several times and get the idea of why we're putting 0.63 in here and not 0.37. Okay, actually read both of these bullets. This is very, very important, and it's an area that many students have trouble with. So take your time and make sure you get what's going on there. So the first thing we're going to put in here is 0.63, comma, and then as with the other stuff, it's the same, mu and sigma. So 100, comma, 15, close parentheses. We hit enter, and our answer is 104.9778, which I have simply rounded here to 104.98. But again, this little schematic here tells you what goes into inverse norm. The first thing is the area to the left, the second thing is mu, and the last thing is sigma. Here's another problem. Membership in Mensa requires, and there's another typo, requires an IQ score above 131.5. 9 candidates take the IQ tests, and their summary results indicated that their mean IQ score is 133. Let's make sure we understand what they're saying there. 9 candidates, people who wanted to join Mensa, took this test, and their average or mean score among those 9 candidates was 133. Now they tell us IQ scores are normally distributed with a mean of 100 and a standard deviation of 15, just like in the other problems. Here's the first question. If one person is randomly selected from the general population, find the probability of getting someone with an IQ score of at least 133. This is exactly like problem 2 above, so I'm going to go through it quite quickly. Let's first of all, we know that it is a type 1 problem because it says find the probability. Now let's see what our curve and our shaded area look like. We are finding the probability of getting someone with a score of at least 133. That means 133 or more. So here's what our shaded area looks like. It's pretty small. There's 133, and there it is going to positive infinity. That's our shaded area. So this is going to be the left boundary of the shaded area. This is going to be the right boundary of the shaded area. So with our calculator, back to second VAR's normal CDF. Second VAR's normal CDF. The low is 131.5. Remember, this is the low boundary of the shaded area. The high boundary of the shaded area is infinity. So low boundary 131.5, comma, positive infinity 1 E99. Mu, the mean, is 100. Sigma, the standard deviation, is 15. Close the parentheses, hit enter, and the answer is 0.0179, and there you see it. Low, high, mu, and sigma, and there's the answer, 0.0179. But now there's a question B under this same problem, and it asks a different question, and it's very important we focus on the differences. In A, we selected one person, but now we're selecting 9 people. If 9 people are randomly selected from the general population, find the probability that their mean IQ score is at least 133. It's very important that you recognize the difference. Let's read what it says here. Is this type 1 or type 2? The words find the probability, and there you see them, find the probability. They tell you it's a type 1 problem, but it is a special kind of type 1 problem. This is an example of the central limit theorem at work. I'm not going to get into the concept of the central limit theorem. I'm just going to show you how to apply it in this kind of problem. Notice the differences between this problem and the others. Instead of one person being selected, 9 people are selected. And we're finding a probability for the mean IQ score of those 9 people. I call this a type 1A problem. You solve it almost the same way you solve a regular type 1 problem, but with one important difference. We're going to draw the normal curve, and we're going to shade the area we're trying to find, just like on every other problem. The mean is 100. We're going to plot 3 standard deviations above the mean and 3 standard deviations below the mean. But because of the central limit theorem, in this case, we have to change how we calculate the standard deviation. Before, every time we just select one person, the standard deviation was simply 15. But it is now 15 divided by the square root of n. And in this case, n is 9. So we have 15 divided by the square root of 9. The square root of 9 is 3. 15 divided by 3 is 5. So in this case, the standard deviation is actually 5. So it's very important to remember when they're giving you a group of people that you're working with rather than just one, and asking you to find a probability for their mean, you have to take your standard deviation and divide it by the square root of n, and n is simply how many people you have chosen. Well, you'll notice superficially this looks the same as before, but something very important has changed. This used to be 115 because it was the mean of 100 plus one standard deviation of 15. It was 115, another 15, 130, another 15, 145. But now the standard deviation is just 5. So 100 plus 5 is 105, plus 5 is 110, plus 5 is 115. We're trying to find the probability that out of 9 people, their average IQ is above 133. We can't even shade that on here because 133 is off the picture. It's way out here. It's way out here. So what we're finding just from looking at this, that our probability is going to be about 0. So let's do this on the calculator. And I want you to notice how easy this is on the calculator. It's just like all of the other type 1 problems. Everything is the same until you get to the very end, where you take your original sigma from the problem, 15, and simply divide it by the square root of n. The calculator will take care of everything else. So again, we're talking about the probability that x is greater, that the mean of x is greater than 133. So once again, second vars normal CDF, the low boundary of our shaded area is 133. The high boundary is positive infinity, 1 e 99. Mu is 100. Sigma in this case, well, let's do it the way it shows here. Sigma is the 15 that we started with in the problem, divided by the square root, which is right here. So second of 9. Okay? And be sure you get outside the square root sign by hitting your right arrow. Now we're going to close our parentheses. We're going to hit enter. And there's our answer, 2.07 e to the negative 11, which means you take this decimal point and move it 10 places to the left. Excuse me, 11 places to the left, which gives you 10 zeros before you get a 2. And that's basically just 2, or just 0 plus. So that answer is 0, just like it sort of told us from our diagram. And that is the end of this presentation.